Problem 7-3, determine the internal normal and shear forces at point C, which is just to the right of the 1,500 pound-foot moment. So let's start by finding the reactions. We're going to have a vertical and horizontal at A. And this is a rocker, so it's going to be perpendicular to the contact. It will have an X and a Y component, but we know the direction. And since that is 30 degrees, then the angle between the X and the Y will also be 30 degrees. And we can solve for that. So let's start by summing the moments about B. So if we sum the moments about B, we got 1,500, that's negative 1,500. And we got the 500, so and that's going to be positive, plus 500 times the length 12, so that's the load, 500 times 12, and then the distance is where that acts in the centroid, or 6, minus AY times 12. And that equals 0. So you can solve AY equals 2,875. Now let's sum the moments about A. So we can find the reactions at B. So about A, we have 1,500. Again, that's negative. We also have negative, now it's acting negative, 500 times 12 times 6 plus B. Now we're going to, the horizontal doesn't matter, it goes through A. So all we need is the vertical. And so the vertical is going to be the cosine of 30. So we're going to do B cosine 30, and the cosine of 30 is 0.866. So 0.866 B times 12 equals 0. So B equals 3610. So BX is going to be, here's B, BX is sine 30, so that's going to be 50.5 times that, so that's 1805. And BY is the cosine of 30, 0.866B, so that's going to be 28, nope, I guess we don't really need to know that, because I'm going to sum it from the left. So I didn't write down what that was. So let's redraw the beam. So we got AY here, and we got AX. Now if we sum the forces in the X direction, all we have is BX and AX. So BX is equal to AX also. So this is 1805, and AY was 2875. Now we have we're going to C right here. So we have a distributed load. It's probably long enough. Distributed load of 500 pounds per foot. And we have a moment, because point C is just to the right of the moment. So the moment is going to be on there. And then we have point C. And at point C we have a moment, M at C. We have a shear, V at C. And we have a normal at C. So if we sum the forces in the X, all we have is AX and NC. So NC is equal to AX, which is equal to 1805. 1805. Now we'll sum the forces in the y. 2875 up. And then we have minus 500 times 6 down, plus the shear at C up. So BC is equal to 1805. No, sorry. Negative 125. It's going to be 2,875 minus 3,000. Now we'll sum the moments about C. If we sum the moments about C, we've got about C, 82875 times 6, and that's going to be negative, plus 500. So here's a distributed load causing rotation this way about C. So 500 times 6 times 3. Again, this is the force, right? And that's the distance. And we have negative 1500. That's the moment. And then we got plus the moment at C. And that all equals 0. So the moment at C equals 9750. And that's going to be pound-feet.